In computer programming, an anonymous function is a function definition that is not bound to an identifier. Anonymous functions are often arguments being passed to higher-order functions, or used for constructing the result of a higher-order function that needs to return a function. If the function is only used once, or a limited number of times, an anonymous function may be syntactically lighter than using a named function. Anonymous functions are ubiquitous in functional programming languages and other languages with first-class functions, where they fulfill the same role for the function type as literals do for other data types. Anonymous functions originate in the work of Alonzo Church in his invention of the lambda calculus in 1936, in which all functions are anonymous. In several programming languages, anonymous functions are introduced using the keyword lambda, and anonymous functions are often referred to as lambdas or lambda abstractions. Anonymous functions have been a feature of programming languages since Lisp in 1958, and an increasing number of modern programming languages support anonymous functions. Anonymous functions are a form of nested function, in allowing access to variables in the scope of the containing function. This means anonymous functions need to be implemented using closures. Unlike named nested functions, they cannot be recursive without the assistance of a fixed-point operator or binding them to a name. Uses. Anonymous functions can be used for containing functionality that need not be named and possibly for short-term use. Some notable examples include closures and currying. Anonymous functions are a matter of style. Using them is never required. Anywhere you could use them, you could define a separate normal function that accomplishes the same thing. Some programmers use anonymous functions to encapsulate specific, non-reusable code without littering the code with a lot of little, one-line normal functions. In some programming languages, you can define an anonymous function that is custom-tailored to give you exactly what you want, which is more efficient, elegant, and less error-prone to certain operations that involve fixed values. All of the code in the following sections is written in Python 2x. Sorting. When attempting to sort in a non-standard way, it may be easier to contain the comparison logic as an anonymous function instead of creating the named function. Most languages provide a generic sort function that implements a sort algorithm that will sort arbitrary objects. This function usually accepts an arbitrary comparison function that is supplied to items, and the function indicates if they are equal or if one is greater or less than the other. Consider sorting a list of strings by length of the string. Greater than or equals house, car, bike, greater than a dot sort len, greater than print car, bike, house. The anonymous function in this example is the lambda expression. Lambda x, y. CMP. The anonymous function accepts two arguments, x and y, and returns the comparison between them using the built-in function CMP. Greater than or equals 10, number 11.2, greater than a dot sort, greater than print 11.2, 10, number. Note that 11.2 has class name float, 10 has class name int, and number has class name street. The sorted order is float, int, then street. Closures. Closures are functions evaluated in an environment containing bound variables. The following example binds the variable threshold in an anonymous function that compares the input to the threshold. Def comp. Return lambda x. X less than threshold. This can be used as a sort of generator of comparison functions. Greater than func underscore equals comp, greater than func underscore b equals comp, greater than print func underscore a, func underscore a, true false greater than print func underscore b, func underscore b. func_b true 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 false. It would be impractical to create a function for every possible comparison function and may be too inconvenient to keep the threshold around for further use. Regardless of the reason why a closure is used, the anonymous function is the entity that contains the functionality that does the comparing. Currying is the process of changing a function so that it takes fewer inputs. Greater than def divide. Return x, y greater than def divisor. Return lambda x. Divide greater than half equals divisor greater than third equals divisor greater than print half third 1610 greater than print half third 2013. While the use of anonymous functions is perhaps not common with currying, it still can be used. In the above example, the function divisor generates functions with a specified divisor. The functions half and third curry the divide function with a fixed divisor. The divisor function also forms a closure by binding the d variable. Higher-order functions Python 2.x includes several functions that take anonymous functions as an argument. This section describes some of them. Map. The map function performs a function call on each element of a list. The following example squares every element in an array with an anonymous function. Greater than or equals 1, 2, 3, 4, 5, 6 greater than print map 1, 4, 9, 16, 25, 36. The anonymous function accepts an argument and multiplies it by itself. Filter. The filter function returns all elements from a list that evaluate true when passed to a certain function. Greater than or equals 1, 2, 3, 4, 5, 6 greater than print filter 2, 4, 6. The anonymous function checks if the argument passed to it is even. Fold. The fold reduce function runs over all elements in a list, accumulating a value as it goes. A common usage of this is to combine all elements of a list into a single value. For example, greater than or equals 1, 2, 3, 4, 5 greater than print reduce 120. This performs the anonymous function here as the multiplication of the two arguments. The result of a fold need not be a single value. In fact, both map and filter can be created using fold. In map, the value that is accumulated is a new list, containing the results of applying a function to each element of the original list. In filter, the value that is accumulated is a new list containing only those elements that match the given condition. List of languages. The following is a list of programming languages that fully support unnamed anonymous functions, support some variant of anonymous functions, and have no support for anonymous functions. This table shows some general trends. First, the languages that do not support anonymous functions, C, Pascal, Object Pascal, Java, are all conventional statically typed languages. This does not, however, mean that statically typed languages are incapable of supporting anonymous functions. For example, the ML languages are statically typed and fundamentally include anonymous functions, and Delphi, a dialect of Object Pascal, has been extended to support anonymous functions. Second, the languages that treat functions as first-class functions, Dylan, JavaScript, Lisp, Scheme, ML, Haskell, Python, Ruby, Perl, generally have anonymous function support so that functions can be defined and passed around as easily as other data types. However, the new C++11 standard adds them to C++, even though this is a conventional, statically typed language. This list is incomplete. You can help by expanding it.